So good morning, everybody. So we are welcome to another edition of our weekly program. Apology for the little delay. A few technical issues here. We try to resolve. So I believe we are set. So as we continue with how to learn machine learning and data science faster and more productively, series with the team always let the data speak. Getting better modeling outcome with machine learning is not a matter of going for the best, most complicated algorithm. Rather, it's a function of asking the right questions and using the appropriate algorithm that is able to understand the content of a particular data set we want to model. That's the principle behind let the data speak. Because your friend used deep learning doesn't mean your next project is going to perform by using deep learning. No. The simple k-nearest neighbor may be what you need to get the problem solved appropriately. So always bear this in mind. And our aim and objective is towards making AI and machine learning accessible to all in a very easy way, ethical, also promoting ethical utilization of AI and machine learning and making positive impacts, life-changing impacts positively. So we all welcome you again to another edition of this class. We're wishing everybody a very productive time. I always start by remembering us why you can no longer ignore AI and machine learning. Very important. So the impact and importance of artificial intelligence and machine learning in this era cannot be overemphasized. So you can check out this video link, as you say, part 1, part 2, and part 3 of a video where we comprehensively analyze and discuss why you can no longer ignore AI and machine learning. The earlier we can, the better. So then we introduce us to the iterative machine learning modeling framework, which is generic, because we used to use it. You have your data, get your data, check the modeling, make it ready for analytics, check the modeling, check the outcome. If performance is okay, it's not okay, you can go back. What do I go back to do? You may also need to go back here. What do I go back here to do? You may need to go back here. What do I go back to do? Hence, the reason why we propose this, what I call the modified iterative machine learning modeling framework to support let the data speak approach. See here, if you do the modeling on the original data set, you can always go back here to do what? You can do the hyperparameter optimization. You may need to change the algorithm if that algorithm you are starting with doesn't work. So, and the rule of thumb is you start with simple algorithm. This is a big principle in machine learning that a lot of people are ignoring. So it's not about complicated algorithm. It's not about latest algorithm. It is about getting the problem solved. What is the essence of using the most powerful algorithm or most recent algorithm? But the real problem you are solving is not getting solved appropriately. You're getting like 70% because you have to use, let's say, for example, deep learning. Meanwhile, you could have used support vector machine and you were able to achieve 99 or 98% accuracy. That is why the principle of let the data speak is very sacrosanct. So So always bear this in mind. So you do the hyperparameter optimization. When you go back here, you change the algorithm. It's also here. When you go back here, you can change the algorithm. I started with KNN, naive Bayes, decision tree. I keep going, SVM, and see which one works for your data. In the worst case scenario, we may have to go for ensemble, because sometimes you may not be able to have any algorithm that will understand the insight in the data you are modeling. Data coming in different form and with different place, in which case one single algorithm may not, no single algorithm that may be able to work model for you appropriately. At that point, you need to go and ensemble. However, I usually advise people, before you go ensemble, try to go back, because ensemble takes a lot of time in modeling. You have to build several algorithms, and you have to build several models, maybe like 151 models, and then try to combine them together in a unique way using stacking. Either you use bagging, you use boosting, or you use stacking ensemble combination types. So that takes a lot of time. So maybe this problem may be something you can solve by just using average algorithm. Go back here, do some feature engineering for it. So do transformation, data downsampling, feature selection, feature reduction like PCA, principal component analysis. You may also need to do data transformation, normalize the data. See, this is very common in day-to-day data analysis. We've seen people, the moment they get their data, they normalize. Except there are some issues in the data that the original data is not going to allow modeling. Don't normalize originally. Let the data speak. Let's see the performance of the original data first and foremost. You have that liberty to always go back. You have the liberty to always go back and do further modeling. It is when the original data is not speaking well with you, you are not getting the message of the data, the algorithm is not able to make my model to be able to detect what the data is inherently possessing. Or every data comes with its own insights. But a human being may not be able to see that insight. This is why we need machine learning modeling to be able to do what? To bring that insight from the data. You may be data rich, but you are insight poor, because you are not able to make sense of what is inside your data. So that is the essence of using smart and the appropriate method to make sure that you don't miss the insight in your data. So the insight may be discoverable with the normal data without normalization. So that's why you need to have an experiment where you have original data set. You have another experiment where you have normalized data set. You can compare them. Which of them is giving me better result? This is very important. And that is one of the principles of letting the data speak. Sometimes you may have to even do log transformation to address the issue of skewness in your data, and also further feature engineering process you may do. Sometimes data cleaning may become even more necessary, handling missing value, outlier treatment, identify reduce noise. Yeah, it may become very important. I say because some people believe you must do all the cleaning from the beginning. No, speak. Check the raw data. Maybe it's speaking well already. Why waste your time doing so many preprocessing? There are so many preprocessing methods you can do. Why wasting time when the original data is already having the insight clearly, just waiting for you to plug in the right algorithm and to start pouring out insight for you? That's the principle of let the data speak. So later, if you are not able to get the insight you are looking at, then you may start going back and then trying to say, okay, can I do missing value treatment? Yes, somebody may be wondering, so can we run experiment even while you have missing value? Yes, you can run experiment. There are some algorithms that support missing value, like decision tree and its family, decision tree, random forest tree, whatever. All the algorithms that are related to decision tree, they can model your data in the presence of missing value because they have that capability. So they have inbuilt capability to take care of that. But why other algorithms may not? So if you want to move to other algorithms, then, for example, support vector machine will not allow you to have missing value. You need to fix it. Then it will become very important for you to handle missing value. And you also have to pay attention to how do I handle the missing value. The best way is for you to go back to the original source of the data and get the value replaced with the correct one, if that is possible. That's the best way. We always want to model with original data set. See, that is why when you do too much preprocessing on your data set, you may unknowingly be doing what I call data mutilation. See, when you mutilate the data so much that it's so much far away from the original data set, and you may not be able to get the insight you are looking for. So that's why it has to be gradual. And then the multi-channel approach has to be upheld. See, run different, let people, you have a team, and that's why data science is better done in a team. Let different members of the team run different channel of the pipeline. You are using original data, you are using normalized data, you are using feature selection. Keep combining different combination of processes until you're able to get the one that gets you the best result possible. So that is the essence of the framework. And you can relate with it irrespective of your background. You keep checking the performance improvement. As soon as the performance improvement is satisfactory to you, then you can stop. Where are you going to stop? No one can tell you from the beginning. Which algorithm is the best? Nobody can tell you that, because indeed, there's no algorithm that is best in all situations. So you have to make sure you let the data speak. This is very, very important. Now, for the sake of especially our members who are just joining us, we created list of videos for us to watch, since we cannot always keep going back to what we taught before in the past. So we made carefully selected watch list for us, which I recommend, especially if you are just joining. Make sure you join our platform, the WhatsApp group, so they continuously they're going to be forwarding the necessary guidelines for you as new members, especially. So make sure you watch these 4 videos. It's about summarized revision of machine learning concepts and how to use it. So once you are done with that, and within, you go to these 3 other videos. So in the one I call Hello World Machine Learning. So you build your first machine learning model in weaker environment without programming. I don't know how to code in Python. That's not your problem. And that is one of the principles of our training. Everybody is welcome. No one should be excluded from learning the technology that is changing the world just because they don't know how to code. No, that would be an injustice against those people. Most of machine learning, AI, they allow a lot of platforms that allows you to learn, build machine learning and AI without writing a single code. But if you know how to code, that is a plus for you. That's highly welcome. However, for those who don't know coding, you don't need to fear. So watch these videos. By the end of the first one, you will build your first model. And for information, these 4 videos and these 3 videos, you can finish everything within 2.5 hours. It means just in 1 afternoon is enough for you to quickly run through these videos and you start building your machine learning based model. This is very important. So you're doing it for the first time, don't you miss a lot. You are welcome. It's still very big opportunity for you. You can meet up, watch that, and note down your concerns, your questions, clarifications. And that is one of the reasons why we sustain this Saturday program, we have a short lecture, and then we give time for people to ask questions. People who have been watching the videos, people who are learning, people who are already professional also try to clarify some things. We give them time to ask those questions. So towards the half of this program now today, we will move to the question time so that you can ask your questions or any clarification for those who are already watching. But definitely, to get hold of anything, you need to make effort. That's why I strongly recommend for us to make some extra work, watch those videos, and you are going to find them very interesting by the grace of God Almighty. And I say, irrespective of your background, you can always work with it. See, those from diverse background, think of and brainstorm about your area of specialization. What is your interest? See how you can utilize machine learning model towards improve outcomes. Get data set there, build your first model. Think for that, how can you improve the one you built earlier? Maybe you already published it, move to the next stage. And then you can also build hybrid, ensemble, or more sophisticated model. To the people from computer science, the world is looking for you, waiting for you to look at their problem, environmental problem, health problem, so many problems that you can use AI machine learning to solve. Build the first one, see how you can improve upon what you build, and then develop new algorithms also, ensemble new hybrid models that towards making life easy for people. Why always remember that let the data speak framework. Always make sure you don't mutilate your data so that you can get the best possible outcome. So always remind us, start with raw data set before applying too much pre-processing. Always do the iterative process. You can always go back. You have that freedom. So there's no rush. You don't have to do 15 pre-processing on your data set at a go. And that is used to be the problem of the classical pipeline. You do a lot of pre-processing the pipeline. What you're having finally may be what I call mutilated data. Your data is almost now a kind of artificial data, not natural data set. You mutilated them. We don't do that. So that's why let the data speak said. Start with raw data as much as possible, while you keep adding pre-processing as the need arises. Remember, machine learning is not a dogma. Try different algorithms and options. So no algorithm is better. When you ask somebody who is doing AI machine learning, which algorithm is the best, and it tells you, oh, it is support vector machine. For example, I've used support vector machine so much, and with most of the time always getting the best result for us. However, that does not make it to be the best algorithm, because we have also used it for very simple work that it doesn't perform. That means the algorithm capacity and capability is a function of the data set you are using it on. That is why we say that machine learning is not a dogma. It's not something that is fixed. You try different algorithms and options, and always know the principle that you start from simple algorithm and progress to more complicated as the need arises, so that we can always let the data speak. You take the next step based on what you can deduce from the data modeling outcomes so far, and this is where experience matter. So note down your questions. If it becomes very urgent, you need to continue, you don't want to get stuck, you can always private chat us or put your question on the platform. Somebody will be there to answer you so that you can proceed with your practice and not get delayed. So the more you practice, the better you become as a practitioner in data science, machine learning, and AI. So always keep the work going. Also, other resources we usually recommend for us, can check them out. So let the data speak, the book itself, can get here from seller.com. Highly recommended. So see what is the let the data speak, what it's all about, what can you do. Also, those videos we gave to you for free in the previous slide, these videos are made available on our platform always. Yeah, the same video will be put together because some people like formal courses. In a course, you can get them from Seller, it's 2.5 hours. A crash course that you can start building your machine learning modeling within 2.5 hours. So Then, so enroll. You can also check it out from Udemy. This is very important. You can check it from Udemy. So also we have writing machine learning based research papers. So want to write research papers. How do you do that? We also have the course for that. You can check it out there. This material is also being provided for us in our platform. So always remember this. Yeah. We also summarized for us last week how you can make a machine learning very much easily understandable to a layman. You see, so when you talk about machine learning, any system where you recommend, you can represent as y is equal to f of x. So y is the output, f is the hypothesis function, f is the hypothesis function, x is the input, which you call the independent variables. So yeah. So once you know the output, during the training, we usually have two stages. We have training and then we have testing. So during training, you know why, we know the output. This is known. X is also known, which is the input. It's also known features. We also call it features. This is the official name. The technical jargon for it is feature. Those are the features. It could be X1, X2, X3. Different characteristics of the material you want to model. So X is the feature. It's also known. Why F, during training, we don't know F. This is what we are looking for. So we keep giving inputs, the feature, and also the output of that feature to your machine learning algorithm. It start to understand it until it is fully trained. Then you have your F now known. That F, now you go to testing. During testing, Y is not known. We are looking for Y. We are looking for the output. Then X is also known. And F is known now. Because you already gotten your F, that hypothesis function, you got it from the training outcome. So you are looking for Y. So I can now say Y is equal to F, give me the characteristics of that person or that particular material, X1, X2, X3. This one, F will automatically generate the outcome, and you can know your Y. Usually say, during testing, Y is equal to F of X. This X prime, X must not be in the training set. This X prime is not in the training set. It's different from the Y is equal to F of X during training. So, and that is why you always divide your data into 2 or 3 as the case may be. And we mentioned that last week also in what we call generalization. Under the generalization, we can refer to the elaborate video we recorded last week that discussed generalization generally. So where the essence is we want to check the performance of the model. That's the most important. So you train, you test. And we said there are 2 ways to do that. We have the holdout method and we have the n-fold crowd validation. All these were clearly explained in last week's video, which you can check it out on our platform. So describe practically how to break the data. So especially if you have 2 or if you have 3 sets, if you have more data set, you break it down into 3. Training set, validation set, and then testing set. But you have very small data set, you break into 2. Training set and testing set. And then the training set, you use it for training and model selection, hyperparameter optimization, using crowd validation. But you don't use the testing set for hyperparameter optimization. Take note of that. These were all well explained in last week's video. We can check it out. We also explained the 10-fold crowd validation, where you partition your data. You can use this for when you divide your data into only 2, training and testing, 70% training and 30% testing. You cannot use this one for hyperparameter optimization. Then you can use this 70% through crowd validation. And then as you are running it, it's not working, you change the upper parameter. You change the upper parameter. Once you get the upper parameter that is working for this 70%, then you now use this 70% to train generally, and then bring in this to come and test. But on no account should you use testing set to check for hyperparameter optimization. Because in that case, you are linking your testing set to your model, which is a fraud, which is not correct. A lot of people still do these things, but it's not a correct way. Because your testing set already understand the way your model is being trained. So it's not allowed. We discussed all this last time. And then we summarize with this. When you have a kind like you have a training, it could be image, it could be anything. So once you do the training, you have the image coming, the features are coming up. You are telling them the label. This feature is apple. The next one is tomatoes. The next one is this. That is called training. You are training under the supervision of a teacher. Finally, you are going to have the F, which I call the processing function. We know this is the Y. Y is coming out from here. Label. The Y is the label, the output. They are giving you the output. This is the X, the input, the features. This feature coming in is a tomato. The one coming in is apple. Once you have enough one, then you have a learn model, which you call model, or we call it hypothesis function. Then we can then bring that model down, extract the feature of this from this image, and then you bring this learn model, bring it here, let it, you cannot this time around, we are not showing the output to it anymore. Even though we know the output because the testing set, but you keep the output away. You let the model that you have trained, let it predict the label of the test set. Maybe you have like 30%, that is like maybe 300 samples. After 300 samples, you now compare with the label you are having with you. The model will generate 300 labels. For this sample 1, this is the label. Sample 2, this is the label. Then you now compare with the one you are having. Then you can decide which one is correct. Maybe out of 300 samples, 295 were correctly classified, while you have 5 errors. That will be 295 over 300 times 100. That's how you calculate the percentage accuracy of your model. But please note that on no account should you ever use testing set to tune the hyperparameter of your modeling, because that is invalid. And this is a generalized supervised machine learning framework where you have the starts, you are going to gather, we call it data preparation stage. This is the learning from data, and this is carrying out prediction and interpreting result. So you have the start, you have to gather your data, you have data preprocessing. This one I said is optional, you have to do it with care. Don't do too much preprocessing. Let the original data, first of all, be used in the modeling. It is when it is not okay, you can always go back. You can always go back to do your preprocessing as much as possible. But note that preprocessing, like missing value treatment, outlier detection, and most of other preprocessing we do, they are optional. However, some pipeline made it to be like it is compulsory, which is one of the reasons why we've seen several projects that are supposed to be successful, but they are not successful because the pipeline already mutilated the data. You've taken out the essence of the data. What you are left with are more of artificial data set. And then there's no way you can get what you are expecting. So it depends on the nature of the data. So this is where you learn from the data, build the data, check it, you say, okay, this is parameter tuning. This is the one I say you must use the test training set for. Don't use testing set here. Then validate your model, either using cross-validation or using the one you have. Then finally, you have the final model testing, do the prediction, analyze your result, identify hotspots, which will be recommended, which should be part of the future work that you want to do. You can't finish a research one. There's always going to be what you want to add later in the future. And last but not the least, for the day, always know that we have several applications, areas you can put this into. But something is unique. You see, it's in speech and handwritten recognition, autonomous vehicle, data mining, playing games, fraud detection, spam email detection, market basket analysis, customer relationship management, churn prediction. You want to know your customer that may run away, credit scoring, fraud detection, optimizing in manufacturing, medical, so many applications, telecommunication, quality of service optimization. Try to understand the customer that may run away. and host of others. Something I want you to know today is the applications are diverse, so huge opportunities. But the unique thing is methods are generic. So if you understand how to use it for one, you can easily adapt it to use it for another problem. So that is why it is a big game-changing technology. You see, so many areas you can apply it to. I know people who are into chemistry, they started using machine learning for their chemical reaction prediction. Instead of spending 2 weeks in the laboratory before they know the outcome of a chemical reaction, they already use past data. Past data set to train the model, and now the model will predict for them this is going to be the outcome of this reaction. They still go ahead to do that, but they found out the prediction of machine learning is exactly like what they are going to get. They get finally. They use it to validate and to test their model. These same people who are in chemistry now, today they are building data science solution for market analysis, for businesses. They were chemistry people, but today they are doing data analysis for people from the business world. That is the unique thing about machine learning for modeling in data science. See, the applications are diverse, so many different types you can do, but the methods are generic. And it is in this view that, by the grace of God Almighty, next time we're going to revert back to trying to build, trying to tell us how we can use this in some selected areas of application. We're going to be concentrating on selected areas of application. We already did for agriculture. You can check the video in our archives. We did like almost several weeks of discussion on AI and machine learning in agri. We started with plant science as plant production. Then we moved to animal production. We can check out those several videos on it. That was the phase 1. We moved to phase 2, where we discuss extensively how we can use AI and machine learning in conflict, security, peace, and resolution of these conflicts, and preventing safety, conflict, security, and all related to this. We had the second phase was devoted to that. We also had several weeks of engagement on it. You can check down the videos on our platform about that. So God willing, we are going to move to selected applications again. We're targeting business administration. We're looking to economic and national planning. We're looking to psychology and social behavioral studies. How can we use AI and machine learning to do modeling of their data, to analyze it, to take advantage of this data so that we can, we are human being are data rich, but the insight, we are insight poor. We still need a lot of work to be done so that we can pick insight from those data that is just wasting away. So God willing. So whenever you have opportunity, check out those videos on agri. The good news is once you know how to analyze for agri, you can also apply it to your own area. And everybody is into agriculture. Either you are a farmer or you also eat what comes from the farm. So again, peace, security is also for everybody. Everybody wants safety. So you're also going to enjoy those kind of video recording. Check them out. We move to business administration. Either you're a businessman or you patronize business centers. So everybody also can relate. But the unique thing is, I also suggest type in the chat box today your area of interest that you want us to look into later, that we can also discuss how to use AI and machine learning in your own specific areas. Type them out. Our coordinator will pick them and we will put them on the list of to do for us. So, but going forward, all things being equal, we hope to look into business administration and then some other ones that we already itemized. Uniquely is if we are discussing application of to any area, it's also good for you because once you know how to use it in one area, you can easily apply it to your own area. So we'll give room now for people to ask questions because of our time. Thank you very much for listening. Wishing you all the best. Thank you. So if you have questions, you can raise up your hands for recognition. Raise up your digital hand for recognition so that you can ask your question. Okay, somebody suggesting material science and mineral processing. Somebody is suggesting geospatial application. Let it keep coming. Yeah, in economy is already on our list. So economy is already on our list, taken care already. Power and energy studies, thank you very much. Keep it coming, keep them coming. So I believe the coordinators are taking care of them. So yeah, so accounting also is there. Thank you. Okay, we recognize Dr. T. Mujisola, coordinator. Please, yeah, you have the floor now. Okay, you have the floor. You can unmute yourself, and then thank you.
Thanks so much, Paul, for the usual class and the nice presentation for this morning. Thanks so much for everything, sir. Yes, I was actually the one that put the material science and mineral processing, and before you even said it might be on business administration and whatsoever, I thought I will have the first chance. But however, everything you said is taken, but at least that one should be in pipeline. That is number one. Number two, yesterday I think we're having IBR proposal defense in my school, IBR institution-based research grant application, and a guy from computer science was presenting on the issue of, I think, developing a model or algorithm for a model for risk-prone area prediction whatsoever. And while doing that, he was mentioning true positive, true negative, or whatsoever.
Negative.
Then, yes, thereafter, when he landed, I now asked him that in your performance evaluation, are you contemplating on a course of dimensionality? I think he got lost in what I was saying. He said no, that he's not considering that, and that is not even part of what he has said. So how do you intend to measure your performance? He said then he has made mention of the issue of true positive, true negative. Now, one of the panelists was saying, okay, that is fine, Dr. Mojisola, but what is so different and special about a course of dimensionality that can I just bring it on the table? Even myself, I got lost. Also, me that was raising an issue, I got lost. Okay, now said okay that I should see the guy. I can have a private discussion with him after the presentation. Now, my question now is,
okay,
sir, what is the position of the is course of dimensionality an performance evaluator? And what is the relationship between course of dimensionality and this area of true positive, true negative, false positive, and so on and so forth? Thanks so much, sir.
Thank you very much, the coordinator, for that. That is a very important question, and to mention. Meanwhile, I kindly suggest that coordinator assign one of your boys to collate some of these suggested topics to look into. They are coming. Environmental sustainability, that's also an area I think I already penned down. So very, very important. Veterinary medicine also is there. So let us have the list. So we'll see how we can handle them one after the other. By grace of Almighty God.
Well noted,
So
sir.
yeah, somebody also wanted him or her to be added to the platform. Please, somebody should share the link to join the WhatsApp group in the chat, please, so that everybody who may be here for the first time can join the group. Thank you very much, all. So now we move to the question. very instructive question. You see, when you talk of cost of dimensionality, it is written as this. A lot of people don't know it is really the cost, actually. The Arabic, we call it lana. It's a cost. It's like costing something. So we call it cost like this. Cost of dimensionality. Yeah, so it's not everybody that is aware of it. So maybe that's why that the presenter was not able to come up with it. Everybody pray not to have this problem because it's a big issue. However, how do you express cost of dimensionality? Dimension means the size. It has to do with the size of your data. So the more the number of features you have, then the more the possibility of suffering from cost of dimensionality. For example, it's generally believed that if you have one feature, X1, you need 10 samples. 10 samples. You need 10 samples to be able to do reasonable analysis on your data. How did they come about that 10 samples? They wrote it this way. They said, let's say you have 10 samples. You have 10 samples. Each sample can stay here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They say, for example, only one feature. So they fill the entire box. If new sample is coming and comes and got there, this guy, if this guy is class A, then this one that falls here will be class A automatically. If this guy is class B, anybody that falls into this will be class B, as an hypothetical case. Now, when you have X1, X2, you are expected to have 10 raised to power 2 samples, which is going to be 100. Now, imagine you have 100, you have now 100 spaces. You are expected to fill 100 box because that's what 2 feature will do. That's what 2 feature will do. So you have 100. Bear with me. Yeah, draw it. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 in 10 places. That's going to be 100. But you are still having 10 samples because the sample sent to you by your client is fixed. So you have one here, another one here, another one here, another one here. The 10 are scattered. They are not able to fill the 100. When your data become 1, X1, X2, X3, you have 3 features. You are expected to have 10 raised to power 3 samples, which is 1,000 samples. So as the number of features in your problem increases, the number of samples that is needed to get reasonable results increases in an exponential manner. And it is generally agreed upon in mathematics that exponential growth is not solvable for now. When something grows exponentially, you can't solve it. So when I have X, your feature to be 4, X1, X2, X4, X4, you are expected to have 10 raised to the power 4. That is 10,000 samples. Now, let me give a scenario. We got a data set from oil and gas company long time ago. They sent us 15 samples, 15 features, 15 features in permeability prediction, gamma ray, this and that, ROB, ROB. Now, 15 features means ordinarily I'm supposed to have 10 raised to the power 15 samples, but they only gave us 335 samples. 335 samples, even lower than what I need to be able to solve 3 features. I need 1,000. But here they are giving me 15 features, and I needed 10 raised to the power 15 samples to get something good done. But they gave me only 335. This is what we call cost of dimensionality. there's no way your modeling will be able to scale to it. To solve this problem, what do? I send message to the client. They said they don't have extra samples to give me. This is the only thing they have. To even get this one, it took them how many years? We now go back to drawing board. 15 features, 335 samples. We run it. Always let the data speak, please. Let the data speak. Run the experiment using 15 features. See what you are getting. You are getting like 50% or 40-something% sometimes. We now went to what we call feature selection. Feature selection, which we mentioned at the beginning of this lecture today. Feature selection is one of the feature engineering options. In feature selection, we now look at these 15 features. They are not all contributing the same way. Can we select the most probable one that can contribute better, so that when I reduce the feature, for example, if I'm able to reduce the feature to like 3 features, that means I'm supposed to have 10 raised to the power 3, which is 1,000, but that is still better than when I'm supposed to get 10 raised to the power 15. So when I reduce the feature to 3, we were able to get result like 92%. Using different algorithms, including ensembles, 92%. So this is what we call cost of dimensionality. So when you start presenting for me your proposal, the moment I see you have many features, and it's good to have many features. When you are gathering data, don't ask them to provide you 1 feature or 3, 4, 5 features, because those they did not send to you may be the one that will be better for you. Let them bring as many features as possible. Then you're going to use feature selection methods to check which of these features are better than other, so that we can select the best, and then we can escape the cost of dimensionality. So in essence, the solution to cost of dimensionality is feature selection. So if I was the guy, you were asking the question, how do you want to deal with cost of dimensionality? I would simply say that, considering the number of my features, I have a lot of features like 15. If we suspect it may lead to cost of dimensionality, because we are supposed to get 10 raised to the power 15 samples, but now we are having only maybe 2,000 samples. Then we are going to use feature selection to prevent the problem of cost of dimensionality, because feature selection is a solution to cost of dimensionality. Once you have 50 features with 335 samples, this is grossly not enough samples. So you need to now do feature selection to reduce the number of samples. Imagine I'm able to reduce the features to like even 1. Yes, you can use 1 feature to predict. We did that in one soil contamination problem. Only 1 feature, and it achieved excellent results, and was published in a Q1 journal as a proof of concept. Then, so you keep reducing the number of features, although generally we want at least 2 and above is better. You see, so that act of having so many features and the number of samples you need is increasing exponentially is what we call cost of dimensionality. And the solution to that is feature selection. Feature selection. So I believe we already discussed this also in our previous engagement. You can check out video recording on our YouTube channel. Just search for cost of dimensionality. You see detailed discussion of that with the graphs and every way to make it easier for us. That is on cost of dimensionality. Now, as for false positive, false negative. False positive, false negative is a function of the outcome of your modeling. If your performance is not good, your false positive, false negative may be skewed. Because of our time, briefly, let me show you this. When you say we say false positive, when you predict, usually we have this. Because of the confusion matrix, you can also check out the video we already made on performance measures. So this is the prediction. This is the prediction from your algorithm. This is the actual values. Actual will be here. This is positive. This is negative. This is positive prediction. This is negative prediction. Now, this diagonal contains the correct prediction. Let's say you are solving diabetes problem. You want to predict somebody is having diabetes or not. So now you have, after the prediction, we have like a 50, we have like 50 here. So, and we have here 70. And here we have 10. And here we are having 15. You see, this is called true positive. When you see PP, positive, positive. This is positive, predicted as positive. It's only 50. This is negative outcome before. It is also predicted as negative, 70. I had this 70, 50 plus 70 divided by total. This is 70. Add everything together, the 4. This is 70 plus 50, that is 130. No, 120 plus 25, that is 145. Divided by 145 times 100, that is your accuracy. Now, so we want these places to be more. True negative means the person is not sick, and we predicted him that he is not sick, which is good. 70 people. This one, the person is sick, but we predicted that he is also sick. That is true positive. Those are the correct prediction. So this is false. So this is true positive, TP. This is true negative. Those are the things we are looking for. We want to get 100% in the two, and your performance is 100%. If you get your accuracy to be 100%, then you get 0 here and 0 here. Now, so this is false negative. 15 is false negative. What's the meaning? FN. And this is false positive. Originally, this 15 belongs to positive class, but it has been pushed to negative class. We call it false negative. Somebody who is sick, you predicted that that person is not sick. It's a false negative. It's a mistake. It's a mistake. It's a mistake. But mistakes are more costlier than the other. So now this is a very costly mistake. Somebody came to your clinic, you use AI to diagnose him or her. You are saying 15 people, they are sick of diabetes, but you say they are not sick. So they will go home, enjoy themselves. Suddenly they may collapse. Your AI system is causing trouble. You call it false negative. But AI is 10 people. Originally, they are belonging to negative class. They are not sick. But your algorithm has predicted them that they are sick. We call it false positive. Predicted as false Sorry, please, for the technical glitch. I think I got muted when the system came back. I explained myself. I was explaining false positive and false negative. And I said, when you have false positive, false negative in medical is a big problem, a very serious issue. We don't allow that. It means people are sick. You are predicting that they are not sick. They may go home and get complication. Okay? They may go home and get complication. Okay. Okay. So sorry for that. Yeah. Yeah. Okay. You can hear me now. So I'm using that as an example. That in false negative in medicine, in medical application, is a serious mistake. When you have more false negative mistake, we don't like that model. We will have to build better one. So even though your accuracy, for example, you got accuracy of 89%, but your false negative is 15. Your false negative is 15. Is 15. And the false positive is 10. Then another guy run another thing. This time around, he got 10 false negative, 15 false positive. Then I said, I'll go for this model. I'll select this model for deployment. Why? Because the mistake is making, the cost of it is lesser compared to the first guy. Because when people come to your clinic and you say they are not sick, meanwhile they are sick, it's a problem. Especially, let me use a better example. You have somebody who has this kind of a system, 79, 85 here. You got like 3 false positive, 0 false negative. You know, he's still making mistake here. Even 10, he got 10 positive here. 0 false negative. And it's making like maybe 90% accuracy. Then I have another guy that is having something like this. It's making 10 here. No, it's making 5 here. 5. 79, but 0 here. All the mistake is making is coming from false negative. That's a bad work. But this guy is not making false negative mistake. This guy is not making false negative mistake. This guy is not making false negative mistake. So we go for this guy. If this one is saying I'm getting 95%, we will not go for him because the mistake is more costly. Because if a patient should visit your clinic and you say the patient is okay and he went home to develop complication, you may be sued. Your license may be taken as a medical doctor. So in this case, so false positive, false negative is a means of determining which mistake is more costlier than the other. So both false positive and false negative, they are mistakes, but one is costlier than the other. So false negative is very costly in medicine. But if it goes to production system in companies where you use AI to check your quality before you release it, false positive will be very costly in the company. Because false positive will say that your product is okay, it can go. Meanwhile, it is not okay. Your customer will receive 40 devices. It will take you to Twitter and Facebook and start to blame your company. Your rating will go down. And it may also take you to court. Then false negative is saying the quality is not good, even though it is good. Then you can double check by a physical human quality checker. Oh, it is good. It was a mistake from the AI. That is an acceptable mistake in the production companies, but not acceptable in the medical institution. So false negative and false positive, which one is more costly depend on where you are applying them to. You have to look at the actual cost of misclassification. Actual cost of misclassification. Actual cost of misclassification. Actual cost of misclassification. I hope that clarified the question, the coordinator. Hope that is clear. So I believe that's the question we have today. Please, can somebody post the link for people to join the WhatsApp group, please? No, it's not there. It's not yet in this. It's not in the chat. Please post it to them. So recently, when I was searching for data to work on, I noticed some data tagged synthetic on cargo. Is it okay to use synthetic data? Or are there platforms to give real life data that are not synthetic? Yes, if you go to our channel, WhatsApp group, you see there are a lot of, so many data sets are there, but I don't like synthetic data. Synthetic data means they just produce it, artificial data. I like real life data set, and you have so many of them. Go to UCI repository. Yeah, UCI, some data actually are brought in from UCI. UCI repository is one of the foremost data sources, long time ago. Okay, so check out UCI, and there are so many other data sources. Some of my materials, one of the participants who is already on the WhatsApp group, please look at our archive and forward to the group the introduction to ML document that we share that contain a lot of sources of data set, so that you can check them out. So synthetic data should be the last option for you when you don't have option. But when you have a real life data somewhere, don't go for synthetic data, because synthetic data is not real. So go for real life data, search it, check out several sources. Yeah, thank you very much, Afolabi. Afolabi Elijah already provided archive for the UCI repository. You can go there and check out the data set that some of them are just being uploaded. New one, 2026. You see there, you can click it, arrange it according to the date of upload. So, and the good news also, if anybody has used the data in UCI, they put the reference there. So you can check out that paper, see how they use it and what they achieved. They achieved 89, then your research to start from their own, use similar procedure, try to compare your own with their work. That is how to proceed in this kind of environment. Hope that clarifies, and thank you all for listening. You're all welcome. Yeah, click the link. Yeah, you are Mr. Tolu, is that Tolu Dokwe? You can check the link already provided now for you. The link is already provided, so you can click it and join the platform so that you'll be able to get necessary information and detail. Coordinator, I hope also we already created the suggested topics that they want us to look into. Please let one of your team members help us get those one ready. So thank you all for being here today, and we always encourage us. Let us also benefit others by letting them know about this kind of opportunity, so we can't afford to be left behind in this technology that is changing the world. Thank you very much all once again for coming. I wish you all the best. Thank you.